Okay, in this video we're going to go through the quotient rule of differentiation. In the last video we did the product rule. So in this video the quotient means a function divided by another function. So something like this. So y equals to u over v. So u is a function and v is a function. So the derivative of this is basically v du dx minus u dv dx over v squared. Okay, so that's the formula for the quotient rule. So let's go through that again. So the order is very important here, unlike the product rule, because there's a minus sign. So you hold the v function, you differentiate the u function, take away, you hold the u function, you differentiate the v function, and then you divide it all by v squared. So let's do an example. Okay, so example, let's say y equals to e to the x over x squared. So let u equals to e to the x, so du dx equals to e to the x, and let v equals to x squared, so dv dx equals to 2x. So now dy dx equals to, so I have my formula here. So the first thing we're going to put is v, which is x squared, and then du dx, which is e to the x, minus u, which is e to the x, times dv dx, which is 2x, so it'll be 2x e to the x, over x squared squared, which is going to be x to the 4. Now if you factorize this, so at the top you can factorize by x e to the x, so this becomes x minus 2 over x to the 4. And you can cancel this x with this, this becomes q, so that means e to the x, x minus 2 over x cubed. So that's the final answer. So let's go through that again. So it's an interesting question here. So we have y equals e to the x over x squared. So we let u equals to e to the x, du dx equals to e to the x, v equals to x squared, dv dx equals to 2x. So the derivative is this formula here. So v, which is x squared, so v du dx is x squared e to the x, v dv dx is 2x e to the x, over x squared squared. So I factorize this by x e to the x, and then at the bottom it becomes x to the 4, and then I cancel the x's, and when you simplify you get to this point here. Okay, so I hope that's clear. So let's do one more question. In fact, let's prove that the derivative of tan x is sec squared using the quotient rule. So let's do an interesting question. Okay, so let's prove that. Okay, so let's say prove that if y equals to tan x, then dy dx equals to sec squared x. So that's the question. So prove that if y equals to tan x, then dy dx equal to sec squared x. Now remember, tan x is equal to sin x over cos x. Okay, so let me write that slightly below so you can see it. So tan x equals to sin x over cos x, which means we can use the quotient rule to do this. So our y equals to sin x over cos x. Now let u equals to sin x, so du dx, so u equals to cos x. Okay, now let v equals to cos x, so dv dx equals to minus sin x. There you go. So now remember the derivative. So dy dx equals v du dx minus u dv dx all over v squared. There you go. Okay, so that's the product rule equation. Now let's substitute in. So v du dx, so v du dx, so that means cos x times cos x minus v u dv dx, u dv dx, so that means sin x bracket minus sin x all over v squared. So v squared would be cos squared x. Okay, so there you go. So now cos x times cos x is cos squared x, and minus makes a plus. Sin times sin is sin squared x all over cos squared x. Now cos squared x plus sin squared x is equal to 1, if you remember from the identities which we did last year. So cos squared x plus sin squared x is 1 over cos squared x. So 1 over cos squared x is same as sec squared x, and that is the proof of the derivative of tan x. Okay, so let's just do one more question and we will finish the video after that. So I hope that's clear. So let's just go through this actually. So tan x is same as sin x over cos x. So if you let u equals to sin x, du dx equals to cos x. If v equals to cos x, dv dx equals to minus sin x. So dy dx is equal to v du dx minus u dv dx over v squared. So v du dx is same as cos times cos, which is cos squared, and u dv dx is sin times minus sin, which is obviously going to be minus sin x minus sin x, which is plus sin squared x all over cos squared, and then you simplify and you get the answer. So it's very straightforward. Okay, so let's do a general question which can come up in the exam, and these are not difficult questions, but I think what's important is, like I said in the other video, you make sure that you present it well. If you present it well, you will get it right every time. So let's say we have a question: y equals x plus 1 over 2x plus 3. Okay, so let u equals to x plus 1, so du dx equals to 1, and if v equals to 2x plus 3, du dx equals to 2. It's very simple. So dy dx equals v du dx plus u, so minus u dv dx all over v squared. So v du dx, so that's just going to be 2x plus 3 minus u dv dx, it's going to be minus 2 bracket x plus 1 all over v squared. V squared is 2x plus 3 squared, so that's going to be 2x plus 3 minus 2x minus 2 all over 2x plus 3 all squared. Now if you look here, okay, I'm not going to go through this slowly because this is just simple algebra. You just open the brackets and simplify. So the 2x and the minus 2x cancel. 3 minus 2 makes a 1, so it's 1 over 2x plus 3 squared, and that is the answer. Now that is the quotient rule for you. So we now learn product rule and quotient rule and the chain rule, and we should be able to differentiate literally any function using these rules. So I leave it there and you can practice these questions for home. Okay, so let's do y equals to x squared over 5x minus 1, y equals to sin x over into the x, y equals to ln x over x squared plus 1, and y equals to cos x over sin x. Well, cos x over sin x is same as cot x, and you can get the results using quotient rule. Okay, so I'll end the video there. I hope you enjoyed it. I hope it's helpful, and I'll see you in a different video for the other part of trigonometry.